Hi everyone, welcome to the Spring 2026 TeamsCode Programming Contest, our 13th online coding competition. My name is Zuri.
And my name is Aaron.
We are thrilled to be here with all of you today and greatly appreciate all the support. Before we begin, we would like to give some background on the contest for new participants. TeamsCode is a student-run nonprofit organization that hosts coding contests to promote student interest and activity in computer science. Since 2017 in Seattle, Washington, we have expanded to serve CS students all around the world. Through our contest, we hope to provide students with an insight into competitive programming while creating a collaborative environment to practice and showcase their coding skills. We hope that helped you learn about TeamsCode. Let's get to today's schedule. From 11:30 to 12 is the contest opening ceremony. We'll go over the rules and introduce our sponsors. Coding begins at 12 and will end at 3. You'll have 3 hours to solve around 10 problems with your team. Between 3 to 5, we'll have 2 guest speaker events. And finally at 5, we'll announce contest winners and also hold the raffle. Note that all these times are in Pacific time. Now, let us introduce the partners and sponsors that made this contest possible. TeamsCode's first partner is XCamp. XCamp Academy is a Silicon Valley-based institute founded by Google engineers for middle and high schoolers with a rigorous computer science curriculum, from beginner to international Olympiad and informatics level. Focusing on mastery of data structures and algorithms, XCamp offers coding classes to achieve success at contests like USCO and the AI era. Their meticulously crafted curriculum uses unique teaching methods, proprietary problem sets, and a dedicated platform, fostering a deep understanding of CS fundamentals and AI. XCamp's top-tier faculty features senior engineers from high-tech companies and distinguished students from MIT, Stanford, and UC Berkeley. For competitive programming mastery, their USCO Grandmaster class boasts medalists from IOI, NOI, and ICPC, ensuring unparalleled guidance. Over the past 8 USCO seasons, more than 400 students reached silver and above, including 75 plus in platinum and 41 selected for US or Canadian camp, with 3 representing the US at IOI 2025. XCamp attracts students worldwide. Visit XCamp Academy to begin your computer science and AI mastery journey. Now, let's hear from XCamp.
Computer science and artificial intelligence are the tools that will shape the future. XCamp Academy is a community dedicated to inspiring and cultivating the next generation of computer science and AI talent. XCamp Academy, founded in August 2017 in Silicon Valley by 2 Google software engineers, XCamp takes its name from the variable X, representing unlimited possibilities and opportunities. XCamp's curriculum and training methodology are based on the teaching philosophy of Mr. Xianyou Xu, a Chinese diamond-level international gold medal coach. Our US teaching team is primarily composed of senior software engineers from leading Silicon Valley tech companies and top computer science students from prestigious universities. We're also proud to have the strong support of international and domestic competition winners who serve as mentors and coaches. From beginner-level Python to advanced C++ and competitive programming courses, XCamp offers a structured curriculum designed to support students at every level of their learning journey. Through team-based competitions and collaborative group study sessions, XCamp fosters a spirit of cooperation and builds each student's confidence in their ability to code. As of mid-2025, more than 400 XCamp students have advanced to the USCO Silver Division or higher, including 75 in Platinum and 41 selected for the US and Canadian national training camps. Among them, 14 were newly qualified in the 2025 season, and 3 XCamp students earned places on the US national team, making up 3/4 of the entire team. In renowned high school contests such as Stanford's Proco, UC Berkeley's Calico, the Harker Programming Invitational, and TeamsCode, XCamp students have grown from participants to problem writers and contest organizers. Our students have received 18 MIT offers, along with many more admissions from Stanford, Harvard, CMU, and UC campuses, a testament to their hard work and excellence. At XCamp, we believe every student has unlimited potential, and our mission is to empower them to shine in the AI era.
TeamsCode's second partner is Non-Trivial. Let's hear a message from their founder, Jonah Boucher.
Hello, TeamsCode. My name is Jonah Boucher. I'm the director of Non-Trivial. We are an online free research incubator for exceptional teenagers. We help you connect your academic talents to solving the world's most pressing problems. We ask the question, how can you make a meaningful difference? We know you're talented, but can you connect that to problems and questions that matter? We're a community and a program that helps you explore. Through a Spring Research Foundations program, we give you the toolkit to do impactful research and ask questions that matter. You'll get a world-class community, hours of online support and programming, followed by a summer research fellowship, where we offer $1,000 project grants up to $10,000 in scholarship, direct one-on-one mentorship, expert access, and again, a world-class community of like-minded peers trying to do some good in the world with the academic talents we have. This is all coming up next school year, but we have some things that you can do right now to get involved. First, you can join our referral network. Select TeamsCode to let us know how you found us. This gives you an insider access to the next application cycle so that we know you came from one of our valued partners. We've got a QR code or a bit.ly to join in. Consider this a pre-application before our applications open next school year. Second, if you're eager to get started right away, you can visit leaf.courses, where one of our partner programs is offering programs that are quite similar this summer, where you'll learn to connect your interests to impact. We hope you'll apply by May 1st. So please take advantage of one of these opportunities. We love partnering with TeamsCode, and we hope to see many of you in our programs this summer or next school year. Thanks for all the great work you do already. We look forward to supporting you with more.
We'd also like to thank Art of Problem Solving's AOPS and Interview Cake for their support. Art of Problem Solving develops educational resources for eager math students in grades 2 through 12, including textbooks, an online school, in-person learning centers, and a variety of online applications. They built the tools they wish they had when they were students. Interview Cake is a study tool that preps software engineering candidates for programming interviews. Interview Cake is focused on being the fastest, easiest way to become the kind of candidates companies fight over. Thank you so much to our sponsors. Our contest would not be possible without them. Now onto our prizes. Each member of the top 5 teams in both divisions will receive Amazon gift cards in different quantities depending on placement. In the advanced division, first place $100, second place $50, third place $40, fourth place $30, and fifth place $20. Each member of the top 5 teams in the novice division will receive the following prizes. First place $30, second place $20, third place $10, fourth place $10, and fifth place $10. We will also be having raffle prizes, and you are eligible for raffle prizes if you make at least one submission today. We will be offering 10 Discord Nitro subscriptions and a Red Dragon gaming keyboard and mouse. Before we kick off the contest, we'd like you all to join our Discord server if you haven't already. This will be used for important announcements and communication with the TeamsCode staff throughout the contest. You can find the invite link in the description below. During the contest, ask questions using our ticket bot in our Discord server. I'll give you some time to go to the link and join our Discord now. Now for our contest rules. The novice and advanced division have around 10 problems each. All problems are each worth 100 points. We will be providing partial credit for every problem. Each problem has some number of tests, usually 10 or 20. If you solve X tests correctly for a problem with Y tests, you'll get X over Y times 100 points. Moreover, some problems will have explicitly stated subtasks. For example, a problem with 10 tests may have tests 1 through 5 with n less than or equal to 10, and tests 6 through 10 with n less than or equal to 100. Note that some problems may also have individual test cases inside each test that you must get all correct to get points for that test. The sample tests given in the problem do not give you any points. You will only be competing against other teams in your division. The difficulty of each problem increases progressively as well. Each problem will have unlimited attempts, and the time of the last submission that increased total points is the tiebreaker. To submit your solutions, navigate to the Submit Code section at the bottom of the corresponding problem on the contest page. Copy-paste the code you have written or submit the source file. Each problem has a time limit that your program must run in less time than. C++ time limit is usually 1 or 2 seconds. Java time limit is 2 times the C++ time limit, and Python time limit is 4 times the C++ time limit. For most problems, your solutions must also use less than 256 megabytes of memory as well. Note that specific problems might have different time and memory limits. Please note, if you're using Java, you must name your class main with the N capitalized for every single problem, or else the code will not compile. Also, if your code runs slowly, try using buffered reader and buffered writer for your input and output. Lastly, click the Rank List button at the top right of the page to refer to our scoreboard to see your team's total score. We will be displaying the top teams from each division on stream during the contest. The rank list will freeze 45 minutes prior to the end of the contest. Here are a set of steps on how to log on to the contest website and get coding. I will give you some time to read through it. And with that, you're ready to compete. From now until 12 p.m. Pacific time, we will be answering any questions you might have about the contest. You may ask your questions in the live stream right now, and during the contest, if you have any questions, we prefer you to create a ticket in our Discord server. Specifically, we have a channel called Tickets, and this will be the only channel unlocked during the contest. If you cannot do that, feel free to email us at contact@teamscode.org. If a question is important enough, we will announce the clarification on the live stream and in the Discord announcements. See you guys at 12.
Okay guys, it's 12 p.m. Coding begins now. You should be able to see your problem set on the right side of the contest page once you log in. Please have at least one team member stay on the live stream or Discord for announcements. We'll also have a live scoreboard and the official timer on stream. Good luck everyone, see you at 3. Hey everyone, there's only 1 hour remaining in the contest. Hey everyone, there's only 5 minutes remaining. Finish up your last problem and make sure to get them submitted before 3:10. Only one submission will make your entire team eligible for the raffle.
Hey everyone, the contest is officially over. Now let's move into the guest speaker portion of the contest. Up first is Dr. Chen. Dr. Chen is a PhD from MIT. He is currently serving as the president of the US AI Olympiad, and his expertise includes AI, machine learning, and optimization.
Hey, Dr. Chen, we just want to remind you that you can feel free to begin presenting whenever you are ready.
Sure. Let me share my file. Yeah, can you see my shared screen?
Yes, we can. Yep, we can see your share screen.
Great. So I can get started. Okay. Hello, everyone. Welcome to my talk. It's my great honor to be here in TeamsCode. I know that all of you are focusing on solving those challenging programming tasks, right? But now you may take a break and see another opportunity that you may take that is from the artificial intelligence. I think we are in the right community because what we observed in the past several years is that many people who are taking AI Olympiads are also from previously taking informatics competitions. Okay. So compared to informatics Olympiad, AI Olympiads are relatively young. Here is its history. At the international level, there are two international AI Olympiads. One is called International Olympiad in AI, IOAI. Another one is called International AI Olympiad, called IAIO. Both of these two international Olympiads were launched in 2024. For the United States, we are proud to be a founding country of both of these two international Olympiads. So now you can understand it should be the AI version of the user code to IOI, right? Even for informatics, so in the United States, you have to take user code. And then if you are on a team, you could go to IOI. So for AI, you need to start with USA AI Olympiad. And if you are finally on the team, you could represent the US to go to IOAI and IIO. Okay, so for us, we rolled out our own competitions last year. So this is our second year for our national selections. And our competition's name is called the USA North America AI Olympiad. The reason that we add the word North America is because we are open to students both in the US and in Canada, okay? And please note that if you are in the US, you want to be on Team USA for international AI competitions, then this is the only pathway. So this is analogous to if you want to take IOI or HEOI, so you must take a user code. All right, let me show you some pictures. So we sent two teams to IOAI in Bulgaria in 2024. And then we sent one team to IIO in the same year in Saudi Arabia. And last year, we sent two teams to IOAI in China. And early this year, so this is 2026, not 2025, is a typo. So we sent one team to IIO in Slovenia. And here we were lucky to get a senior official from the US Embassy in Slovenia to come to our closing ceremony to give our students the congratulations. And also, so after the closing ceremony, and he posts the thread in the embassy's social media to show his support on Team USA and our AI Olympiad. Okay, so the AI Olympiad is much younger than other well-established Olympiads such as informatics and math. So one question people are asking is this competition valuable or not? So I will not give you the conclusion, but let me give you some facts, and then you can make your own judgment, okay? So the first is about the college admissions data. Up to the last year, 2025, so our Team USA members have 8 who are at MIT. So actually it's 5. It's a type of 5 at MIT, 3 are at Stanford, and 2 are at Caltech. And for the 2026 college admission cycle, we know that it was just closed last month, right? And in the past 2 weeks, and also next will be Harvard. So the many students will be traveling around the country to visit those universities. So like, for instance, the last week was MIT and Yale, and this weekend actually, even today, so that was Stanford, right? So we had quite a few Team USA members who are accepted by those top tier universities, such as Caltech, Harvard, MIT, Princeton, Stanford, Yale. Okay. And the second fact I want to share with you is that now we are with the partnership and the sponsorships with lots of the well-known companies, such as Google, Jane Street, General Catalyst, Halfway, etc. So for instance, we know that Google is a leading company in high tech, and Jane Street is a leading company in the financial sector, right? And also if you take Usico or AMC, you know that Jane Street is sponsoring all those well-known competitions, okay? All right. And another fact is that for our competitions, we try to put our second and third rounds to Harvard and MIT. Okay. So what about the future schedule of those international competitions? Because to be honest, for a new competition, so you want to see whether it can survive or not, right? So if you asked me this question 2 years ago in 2024, so I also shared the same concern. And now I have no concern at all, okay? So it will definitely continue. For instance, for Iowa AI, so for this year, this summer, it could be held in Kazakhstan. And next year, it will be held in Singapore. And also, I'm a board member of Iowa AI, so I have some inside information. So I know that, so we even have the host country in year 2028 or even 2029. So I can now disclose to which countries will host the competitions 2 years from now, but I can just convince you that you don't have to worry about it, okay? For IAIO, also we found the host for the next year, that will be Vietnam. So this shows that the AI Olympiad will definitely continue. Survival is not a concern anymore. Okay, the next thing people wonder is that you want to be on Team USA. What is the pathway to go to the international stage? So our competition consists of the following rounds. So this structure is very similar to physics, chemistry, and biology. It consists of 3 round selections. Round 1 is open to everyone, so anyone can sign up and take it. And then we look at those who are at the top from round 1. We invite them to the second round. After the second round, we select a very small portion of students to the third round. Also, we call this the training camp, okay? And in the camp, students will do some team selection tests, and then we select the best students to be the team who will take the international competitions. Okay, let me give you more details of each round. For round 1, we require students to take it on site, okay? So you cannot just take it from home. That's not allowed. So you must choose a site. And it must be proctored. And we will enforce both the human proctors and the technology to proctor your competition. Okay? So for the test site, you may choose to take it in your school or in the local college, library, or test center. And in the past years, so we find that some students were in trouble finding a test site. So on our website, you will see a list of the partner test sites, including some high schools, some libraries, some universities, some test centers. So I want to clarify that we do not require you to must pick up a site from the list. That is only for the reference purpose. So in case you are in trouble finding a test site, so you may refer to our list. Otherwise, if your school is not on the list, but you speak to your teacher says, yes, so I want to host the competition for you. That's it. So just let us know. We will add your school to the list. Okay. So it's your job to proactively find a test place. For the first round, we have the following award system. There are 3 tiers of awards: distinguished honor rolls, high honor rolls, and honor rolls. If you are familiar with AMC, you see that the award system is very similar to the AMC. Okay, then the second round. For the second round this year, we invited top 200 students from round 1 to MIT and Harvard to compete. So they competed for the whole weekend, for 2 days. Okay, 1 day was at Harvard, 1 day was at MIT. And after the second round, people will get the following awards. The top students will be called campers. They'll be invited to the third round, the camp. And below the campus level, we have gold, silver, and bronze. And then we have the third round. This year, we selected approximately 30 students to the camp. And we will hold a camp at Harvard. So the training camp will be for about 1 week this year, in early June. And the students there will do team selection test. And then we finally select the students to IOAI and IAIO. All right, so after explaining to you about our selection process, so the next thing I want to let you know is what topics are tested in the AI Olympiad. So many people, in particular from the informatics community, ask me this question. Is the competition similar to USACO? Because it seems that the similarity is both competitions require students to use computers and to program, but they are very different. So they cover different scopes of topics. So the list of topics tested in AI Olympiads are listed here, okay? So first, we require students to have some mathematical and coding background that is needed to do AI, okay? So for math foundation, you need to know some basics of linear algebra, some probability statistics, complex optimization. And for basic coding, so we use Python to build AI models, okay, not C++. And for Python, you also need to know some packages, libraries, such as NumPy, Pandas, Matplotlib, .py. So those are the foundations of doing AI. After having those foundations, next, we can get into some AI-related topics. So one is the classical machine learning. So you need to be familiar with classical machine learning models, including some supervised learning model and supervised learning model, semi-supervised learning models, okay? So for example, you need to know linear regression, you need to know logistic regression, you need to know random forest, you need to be familiar with the support vector machine, the naive Bayes rule, the XGBoost, right? So all those are the basic machine learning models. So you need to know what they are used for, right? Whether they are supervised learning or unsupervised learning, and what should be input, what should be output, and what's the intuition behind those models, and can you build those models up from scratch by yourself? Okay, and what's pros and cons of those models? So you need to have very solid understandings of those classical machine learning models. Okay, all right. On top of that, so we go into the modern AI, that is deep learning. To do deep learning, you need to know another package called PyTorch. Okay, so here I want to point out the following thing. So when people do deep learning, there are two typical programming languages people use, or we call them packages or libraries. One is PyTorch, another is TensorFlow. In our competition, to do deep learning, you must do PyTorch. That is required, okay? So if you are familiar with TensorFlow but not PyTorch, then if you want to take our competition, you need to switch from TensorFlow to PyTorch, okay? The simple reason is because it is more compatible with different versions. When it is upgraded to a higher version, it is compatible with the old one, okay? But that's not the case for TensorFlow. Another fact is that you look at academia and the industry, so vast number of people are using PyTorch, not TensorFlow. And also for the international competition, IOAI, it uses PyTorch. So we need to be consistent, okay? After knowing how to program in PyTorch, so next you can do something with deep learning, okay? So you need to know the deep learning foundations, such as the architecture of the multi-layer perception model and what each layer is used to, what is the input and output, and how to train your model, how to do back propagation, how to define your loss function, okay? So those are the foundational things you need to know for deep learning. After that, you need to be familiar with some advanced topics in deep learning. So one modern model everyone needs to know is transformers, is tested for sure. So if you look at the last 2 years AI Olympiad problems, so there were transformer problems tested every year, okay? It's not just tested in our US AI Olympiad, but also in other countries' national Olympiads and at the international level, okay? Because we know that the foundation of ChatGPT or large language models is transformers. And beyond solving language problems, transformers is used to study computer vision problems, right? So it's so powerful. You need to know transformers. And also you need to know how to use deep learning models to do time series analysis. And you need to know about its applications in natural language processing, in graph neural network, in computer vision, in generative AI. Okay, so all these topics will be tested. But don't be scared. So this is the boundary. So for round 1, we will only test you the knowledges up to here. Okay? So traditional machine learning and PyTorch and the fundamental of deep neural network. That's it. So we will not test you advanced topics listed on this page. That will not be tested. That's too advanced for round 1. Okay? And also for round 1, so you are required to solve all problems that are using CPU, no GPU. Okay? From round 2 and afterwards, everything might be tested. Okay? And also, so some problems even require you to use GPU, in particular in deep learning, that will be used to accelerate your computation. Okay? All right. And the next thing I want to share with you is about our principles of writing context problems. So here's the thing. When we talk about the problem styles in informatics like USACO, or in math competitions like AMC, AMY, USAMO, so there's no doubt, right? So everyone is on the same page. Everyone knows about the context format. For instance, for AMC, everyone knows it's multiple choice. And for topics covered, everyone knows that you need to know algebra, geometry, number theory, combinatorics, probabilities, 4 modules. When you're talking about informatics Olympiad, everyone knows that. So you need to submit your code, submit your function, right? And for each problem, there are a bunch of the grading cases. And they compare your solutions with the ground truth and see whether it's correct or not, right? And also for each function you need to build. So they primarily care about your time complexity, space complexity, and whether you can handle those corner solutions for edge cases. And you have to build everything from scratch, from the bottom. So that's pretty clear, no doubt. However, when we delve into the AI field, we realize that is not true. Because nowadays, everyone's talking about AI. But although they use the same word AI, they talk about different perspectives of AI. So that makes the people to be very confused. So that is something we must clarify here. So what aspects of AI is tested in the AI Olympiad? Okay. So we see some students, they say, oh, so we know AI pretty well, we love AI. And then we ask them, okay, so why you believe you love AI? And could you give me the example? It's like, yeah, so I use ChatGPT to help me solve homework every day. Come on. So first, maybe your teacher doesn't allow you to do that, even though you're allowed to use ChatGPT to help you, for example, find literature. But that's not what we want to test in our competition. We don't want to see who had a better skill to use ChatGPT to help them find literature. No, that's not the case. Or some other people say, oh, so I know how to build the device, maybe a mobile device, right? So I can use this to detect whether there's a pedestrian, whether there's an object, right? Okay, that is good. That's a good project. But again, that is not what we test. It's because, so for their AI-enabled app, right? You look at their AI component. They simply use a well-trained model and then load the model to their mobile device and use it, right? But when I ask those students, okay, so for example, for this object detection app, so what is the algorithm behind it? Whether it is from the YOLO or from transformers, they have no idea. And when I ask them, okay, so how your model was trained? They said, what? What is training? So they've never heard about this word. So just use AI as a black box. That is not okay. And also we saw some students, they claimed, oh, so I did a fancy project. So basically I got some customer reviews from Yelp and I built an AI model to classify whether someone likes this restaurant or not. They do the classification task or sentiment analysis task. So I further asked them, oh, so this seems to be cool. Could you tell me about how did you tokenize those text messages? And what AI model did you use? What transformer model did you use? And for your transformer model, did you try to build your customized head on top of the last layer hidden output? They have no sense. They said, oh, so we just import a model from the Hugging Face, but we have no idea how to train it. We just put everything in the pipeline, put it as a black box. So that is not okay. Because we know that such black box issue does not exist in Math Olympiad or in Informatics Olympiad. Because in AMC, you have to derive everything from scratch, right? And even for USMO, right? So the scores were released yesterday. So you know that you say, oh, I somehow solved a similar problem from, say, I don't know, maybe the Japan Math Olympiad or Romania Math Olympiad, and I directly use the result without giving the proof. So you will not get any point of 0 out of 7. This is also the case for informatics. You can't say, oh, so for this one, I somehow find a paper somewhere and the code is on GitHub. So I load code. No, that's not allowed. You have to put everything from scratch. So that's not an issue for other field. But this is the problem for AI. So many people just try to search online or use ChatGPT to help them search online to find some existing models. And they import the model, they load the model, they directly use it. That's it. And the model typically, AI models are very big. They have no idea what happened inside of it. So that is not the way for AI Olympiad. Okay? So that's something we must clarify. So AI Olympiad should share the same value and philosophy with other Olympiads. That is, we need to test your understanding and creativity of AI. Okay? So in other words, it means that for our problems, we always start from the first principle. Okay? You can't just treat it as a black box. That's not good. So that is aligned with academia and industry needs, and that is aligned with other Olympiads such as math, informatics, physics. Okay? All right. The second thing that is also important is that, so for AI Olympiads, we have both non-coding tasks and coding tasks. So math and coding are equally important. You can't say, I know math, I know theory behind AI, but I have no idea how to program. That is not acceptable. Okay? And in another extreme, if you say, oh, so I know nothing about math, I know how to program, that is also not acceptable. Okay? So both are equally important. All right. The next thing is, so that we heavily penalize those black box solutions. Okay? For example, so if you are familiar with scikit-learn, you know that so everything is a consistent API for different models. So for a model, how you train it, you call model.fit. After training the model, how you use it to do inference, you call model.predict. That's it. So it's the same API for all models, for linear regression, for random forest, for the whatever, right? But suppose this is something you know, and you come to our AI competition, that's not enough. And if you provide such a solution, typically those solutions will give you a very bad result. Okay? So basically, we try to write problems to heavily penalize those who know AI just by treating them as black boxes. Okay? All right. Another thing is, so the reasoning is required for open-ended problems. In round 1, so we give students some open-ended problems, which means that they didn't have lots of restrictions. They can come up with their customized models to solve the problem. Okay? But here's the thing. We don't want them to just do hard coding or do the brute force to try out multiple models they are familiar with, and then they pick up the best one. No. So every problem should be with some reasoning behind it, right? So for instance, suppose you see some data that maybe some two data points that are far away from each other may somehow have some relationship with each other. So probably you have to use a transformer model. And for a data that's highly unbalanced, so you know that you have to use probably the focal loss, not just the KL divergence, or you have to adjust the weight of the KL divergence function, right? So those are with some reasonings, okay? It's not just with a random guess. Another thing we care about is, so when we write problems, we do not want to give you too much burden on memorizing too many syntax, libraries, modules. So this is different from math or informatics Olympiad. For informatics, so you build everything from scratch. There's no library you can use, right? So basically, you don't have to memorize lots of things. Everything is from the basic, the syntax. But for AI, sometimes we have to import some models. Like if you do some CN, right? So maybe we have to use pre-trained CN models, like ResNet models or GoogleNet models. So different models have different syntax, right? So that brings the one problem. Do we have to remember all of them? The answer is no. So for those basic methods, you need to memorize their syntax. That is required. Such as, for instance, if I give you the NumPy array, I want you to change its shape, to reshape it. I want you to swap two axes. So those are basic operations. Or I want you to do broadcasting, do summation, right? So those are basic operations. So you need to memorize those syntax for sure. But for some advanced operations, that is not needed. In case those are required, we will give you hints, okay? So you want to minimize your memory. Okay, and in our competitions, we have two types of problems. So one is the non-open-ended problems. Another is open-ended problems. Non-open-ended problems means that the solution is unique, is deterministic. Either your solution is correct or it is wrong. Okay? No gray area. Okay. So those formats could be like multiple choice, fill in the blank, or we ask you to write a Python script, or you need to make the text explanation. Okay? So those non-open-ended problems will test your theoretical knowledge. And also, so another thing is, many AI models are highly integrated and are at a very high level. But you can't just encapsulate everything as a black box. You need to open it and understand every component. So one example is like a transformer. Transformer is so big. It consists of hundreds of blocks. So you need to understand the function of each single block, right? So those cannot be tested from open-ended problems. Otherwise, you just import a library or a module, assuming it's a black box. So you have to do it as a non-open-ended problem. I test you this particular module and ask you to design it in such a way. I give you input, output, and ask you to do some analysis. Okay. All right. Another thing is, so because we have to test your understanding of those small components, so basically means that the black box is not acceptable, right? And as I explained, that is not acceptable not just in our competition, but also in academia and industry. Okay, so you talk to some university professors, you ask them, oh, so I'm doing AI research. Can I just treat everything as a black box? They say, no, you can't. You have to understand everything, build everything from scratch. If you go to industry, you are looking for an internship or a job. If you tell them, oh, so I only know how to search for an existing model from Hugging Face, they say, no, they cannot hire you, right? So you need to program from scratch yourself, okay? And beyond the non-open-ended problems, why we also test the students the open-ended problems? So the reason was that, so first we test your creativity, okay? There are some open-ended problem like this year. So in round 2, we had one problem that is every matter you think about it as a mass or the charge or some other particle that create a physical field, right? So suppose I give you the physics law, I give you the location of this matter, so how to compute the field, right? But we ask students to solve a inverse problem. That's we give you the field distribution, and we want you to restore the location of the mass. And also, so the field function is not given. You have to discover the field function. So it's an inverse problem. And for this problem, so we ask students to use AI models to solve it. And this tests your creativity, right? So maybe you realize you think about the field distribution to be the image. So you use some image approaches such as a CNN, that's okay. If you think about it as the vision transformers model, you use VIP, that's also okay. Okay, so that's your creativity. All right. Another thing is, so it's similar to user code. So our problems are without the restrictions of which algorithm you should use. So it tests your ability to solve a problem, right? So then you cannot just provide a partial solution. Because for user code, you cannot say, oh, so I finished the 98% except the last line of code. So I don't know how to program. Unfortunately, you get 0 point, right? The same thing here. You need to have the ability to write complete code. And another thing we test open-ended problems that, so you are familiar with category competition. So no AI problem has the best solution, because suppose we want to get accuracy. There's no way to get 100% accuracy. You get a 100% correct answers. So even doubt your solution, maybe it's wrong, or maybe you cheated, right? Because it's not realistic, it's not likely. So you can be close to 100%, but you never attain 100%. It means that there's always some room for you to make improvements. So that's why, so we want to see who is mostly creative and could come up with the best one. Okay. Since I'm presenting in the informatics community, I want to make the following comparison with user code. So why user code or informatics Olympiad or competitions and no non-open-ended problems? Okay. So non-open-ended problems means that, so we have the fixed solution, like the multiple choice problem, like the fill in the blank problem, right? Like for example, the problem that I want to write down the intermediate steps to prove something. So user code doesn't have such problems, but why AI has such problems? So here are the reasons, okay? So for user code, think about it, like today's competition, right? If your code passes the test, it means what? It means that you know some algorithm, like the idea, like how to implement, like time and space complexities. So you know this algorithm pretty well. Suppose I give you the graph problem, right? You come up with the solution for the, say, for instance, the breakfast search. So if you can submit a solution, it means that you understand the math behind the breakfast search. And you know its time space complexities. And you know how to convert your mathematical thought into code. So you know everything, right? And also for some challenging problems, you can't do brute force, right? You have to first think about the problem structure and find some intermediate results that could lower your time and space complexities, right? So this is particularly the case if you go to user code, go in the platinum divisions, right? So it means that although you are not required to write down those mathematical steps, but you implicitly prove their correctness. Okay? So that's for user code's coding problems. But that is not the thing for AI. For AI, as I said, sometimes you use some transformers to analyze images. Probably you have to use a pre-trained model. But we just test you the program in open-ended problems. So how do I know whether you understand those pre-trained model or not? There's no way for me to test this one. So we must use the non-open-ended problems. Okay? So then we know that you could program from scratch, so there's no black box issue. You fully understand everything. Okay? And you can solve a problem, so you both think and correctly and program correctly. Okay? So that's the reason why user code has no non-open-ended problems, but AI Olympiad needs to test you those problems. Okay. The next thing is, so for our community, for TeamsCode community, why I believe that USA AI Olympiad is a good opportunity for you. So first, the AI Olympiad requires you to have mathematical and algorithmic thinking. And for those of you who are already here, it means that you already have such abilities and backgrounds. You are already strong in math. You are already very strong in programming. Okay, so you just easily transfer your existing skills to the AI field. Then you can easily succeed. And the second thing is I want to point out is that some of you may argue, Well, so when doing informatics competitions, I'm using C++, right? But for AI Olympiads, I just said we have to use Python. I didn't use Python a lot. Would that be a problem? No. So now we know C++ is much harder to learn compared to Python. You already know C++. It's very easy for you to quickly pick up Python, okay? And on top of Python, we have to use NumPy, PyTorch. So those are extremely, extremely simple for you, okay? All right. So next, let me talk about the future plan for the AI Olympiad. So for this year's competition, we already finished the second round. For the third round, the camp, we have already selected campers, okay, but we haven't formally announced it to the public yet. We'll probably do it in the next 1 to 2 weeks, okay? We have concluded this year's competition. Looking forward, for the next year's competition, the registration will be open on June 1st this year, not next year, this year. So it's about 1 month from now. The registration will be open, okay? And here's our tentative schedule. And round 1, this year, it was pretty early. It was in late January. But next year, we try to postpone it to mid to late February. So one key reason we want to put it in February is because, so there are 2 reasons. One is about the unpredictable inclement weather. This is particularly the case for those who are on the East Coast. I recall that this year, so on the competition day, so there was extremely cold for many places on the East Coast. So many schools on the East Coast, like the New England, like DC area, they were closed. But we want students to require students to take it on site, so they have no place to take competition. So that's a problem, okay? And you want to avoid this problem to happen, so that's why we want to put it at a later date. Another reason is because if you put it in January, so then we'll close the registration 1 or 2 weeks before the competition. So at that time, many schools were still in the winter break, right? So if the students need to find a proctor, needs to speak to their teachers, so nobody they can speak to. So that's a problem. But we put it in the February, so all schools are open for several weeks. So students have sufficient time, even for the late registration, they have sufficient time to register and to find a proctor. And the second round will still to be in April next year, okay? And another change for the next year's competition is that, so we expect more people to participate. So we have to better streamline our grading process. So for round 1, then we'll try to make problems to be more standardized. For instance, we may give you more multiple choice problems. And for coding tasks, so we may also make everything to be automatic, okay? All right, so then I want to talk about something else. So the supports that we need from you, okay? So we definitely need the support, not just that we give you the opportunity to showcase your excellence and passion in AI, but also we believe that so you can help us a lot, okay? So what kind of supports we need from the public? One is that, so you need to collect the evidence to show that our contestants are very successful. For instance, some people got accepted to some great university. That's amazing. We love to see this fact, right? So like for instance, for today, so it's a Stanford campus day, right? So we had some Team USA members admitted to Stanford and visited Stanford today. They sent us lots of great photos. So we love to see that. That's amazing. And there was a case in the past week. So we saw students visiting MIT, Yale. They sent us lots of great photos. In particular, like the Yale, right? So they put up the big Buddha, right, on the grass. So that was amazing. We loved it a lot. Okay. So if someone got a great internship or job opportunities, where someone did an amazing startup and raised lots of fundings. So those are amazing. So we love to see those stories. Please let us know if you know such stories. And also, we need an endorsement, like to endorse for our problem quality, academic integrity, and student success. So we love to see endorsement from individuals like professors, managers, entrepreneurs, researchers, or students here. And we love to see it from organizations like some universities, like a research institute, like some companies, like some high schools. Okay. And also, so we provide you the opportunity to serve as our ambassadors. So you could just apply from our website to be our ambassador. Okay, so as an ambassador, so what we expect from you is that we wanted to promote our competitions to share the AI opportunities and the cutting edge technologies and applications with your friends. Okay, both from your school and your local community, or even if you are connected with someone online, so maybe you can define your community in a broader way. And also, you may speak to your parents. We need some parents volunteers to help us run everything. Okay. So basically, USAIO and the students, we grow together through a mutually reinforcing cycle of opportunity, achievements, and recognition. Okay. Yeah. If you want to learn more about our competition, so you could visit our website, send us an email, or subscribe to our newsletter. That's pretty much what I want to present. Any question? Any thought? Any comment? Is there anyone who has any question?
Once again, thanks to Dr. Chen for the great presentation. Now, feel free to take a short break until 4:10 p.m. until our guest speaker will arrive and give their talk.
Yeah, if you have any question, feel free to let me know.
All right, up next is Chen Chao. He is a principal engineering manager at Microsoft, where he leads team building, large-scale security infrastructure, and advancing next-generation agentic data center management systems. He brings deep expertise among machine learning, artificial intelligence, distributed systems, and security, with a strong track record of delivering reliable, high-impact performances at platforms at scale. Beyond his work at Microsoft, Chow is a co-founder and board member of Career Up Club and a former president of the Seattle Entrepreneurship Club. and he is passionate about empowering engineers and leaders to navigate career growth, embrace emerging technologies, and build meaningful impact.
Okay, hello everyone. Can you hear me now? Let me share my screen. Okay, I need to. Okay, somehow I need to. Oh, sorry. Moderator, I need your help. I think I need permission to share screen. Okay, give me 1 second. Yeah, I need to rejoin. Sorry about that. Can you hear me now? Okay, can you see my screen now? Let me. Okay, good afternoon, everyone. Thank you for being here today. I'm going to take you on a journey through one of the most remarkable stories in human history. How we taught machine to understand us and then to how code alongside us. This story spans 75 years, but most of action happened in the last 3. By the end of today, I hope you can learn something about the machine history and AI history. I know everyone has long days, so I just give the easy topic for everyone. Quick introduction. I'm Charlton. I'm a principal engineering manager in Microsoft. My team is working on security infrastructure in MC5 Cloud. I host a PhD in machine learning of smart home, which means I've spent my career at the interaction of AI research and shipping real software. besides my daily work, I also co-founded a nonprofit career up club, and I was president of the Seattle Entrepreneurship Club. Today is not a lecture, it's a tool. I'll show you the history, then I'll show you what's possible today. I will give a live demo to build a game. That's part of fun. Let's go. So before the lectures, I also want to do a game. So basically, I can give a quiz about the computer. So you want to participate, you can using the kahoot.it with the game pins 4051992. So let's give the 1 minute. To join the participant. Due to the quota limitations, only 15 participants can join. So we still have a few people can join. Let's give the last minute. Okay, let's start. We have 12 participants. All right, congratulations, Jeffrey. Okay, let's go back to the topic. Let me reshare my slides. Okay, so for this topic, I want to talk about the 4 errors. The first error one is writing by hand. The slow carry for the 70s through the 90s. Error 2, the web exploded. Developers stopped writing everything and started assembling. Error 3, AI learn off code. That starts on a specific date, November 13, 2022, ChatGPT showing up. Error 4, AI takes the wheel. Where we are now. So you just describe what you want to build. AI can do it now. So each area made programming more human. That's the thought line of the whole day. Then, before we get to AI, let's remember what a computer used to be. So this is a 1946 electronic numerical integrator and computer built at the University of Pennsylvania, funded by the US Army to calculate the decade mathematics. 30 tons, 20,000 vacuum tube, 150 kilowatts of power. So it filled an entire room, but it could only handle 20 decimal digits. You wanted to do something you didn't type, you physically rewind it, only trained specialists to touch the machines. So everybody else waited in line and handed over their punch cards. So every program is running for days, and the programmer waiting for days to run the programmings. So you can keep the image in your head, because in about 40 minutes, we are going to jump from this to describing a game in plain English and watch it get built. So you can feel how amazing from the original, very, very old computer. Now we can just use AI to do the job for us. Now, the fun part. So if you can, it's the founders of Microsoft, a founder of the Apple. Before they were billion-dollar companies, they were both teenagers who couldn't stop tinkering. Bill Gates was 13, Paul Allen was 15. They stuck into a company after hours to use their computer. They found so many bugs, they failed a 300-page report. The company DEC eventually shut the program down with the line. So those guys find bugs endlessly. And Paul always told Bill, someday we'll have our own computer. Now the dream came true. On the another side, so Steve Jobs, age 12, he called the co-founder of HP, asking for the spare parts. And he got them. And was the co-founder of Apple, in 8th grade, built a computer out of transistors, won the science fair. He covered his bedroom wall with a computer poster instead of rock stars. So Apple was founded on the April Fool's Day, 1976. So two bored young men tinkering with second-hand electronics. Now the personal computer happens. The personal computer was not invented in a lab. It was built by teenagers like you in garage. So that hacker spirit is still alive. So I think everyone now is participating in the coding competitions. Now I believe you also will have the power to build something you are interested in. It just looks different now, but back then it was the icons, space chips. Today it's a laptop and a conversation with the AI. But the energy is the same. So every generation's programming get more human. So give you some simple task, add 2 and 3. In the 40s, programmer wrote machine code. So literal ones and zero. So you will see now the 10110000 on a x86 chip means move the next byte into the register AL. It's very difficult to understand. You need to remember every single operations. In the 1972, SIG language come out. It's just to show the primitive and with the special format. Before that, we also have assembly language that gave more human readable language. In 91, Python, you can just use the Python just, okay, it's print 2 plus 3. Then the program will show you the output. And today, now it's just at 2025, 2026, you can say it's just in English, add 2 and 3. And the program just show it the output. So every step was a translators. Every step brought the computer closer to us. So here's the point of the whole today. AI is not the latest step on very long laters. It's not the first, but it's the long journeys. So everyone, the 70s through the 90s, so if at this area, you wanted to say hello to the user, you need to write a many line of say, you should declare your buffer, scan, printf, return 0. At that moment, at that time, there's no Google, there's no Stack Overflow. One typo means hours of debuggings. So I can remember when I was kids, I was trying to build some things. When debugging is usually I spend hours to debugging. Even just show the output, it takes a very long time. And it's any single error is very difficult to debug. So now you can just use AI. So you can paste your error message to the AI. The AI can help you to find the issues. But during this area, so Microsoft funded in 75, Apple I shipped in 76, and the IBM PC arrived in 81. And personal computer going to the regular family now. So building software feel like handcrafting furnitures, one piece at one time, and only very few programmers can build a computer, can build a programmer. But later, the internet showed up, the web exploded, and the slow wasn't an option anymore. So era 2, the 2000s through the 2020s. So there are millions of websites had to be built yesterday. So you can see that we have the Uber, we have the DoorDash, we have so many, we have Amazon, so many websites can solving all kinds of problems. And if every developer was writing in the same login page and the shopping carts from scratch over and over and over, so it's duplicate works. What's the solutions? The solution, we stop reinventing the wheel. So most of the developers, you have open source, we have framework library that you assembly app from the pre-built parts. So weeks of work become hours. You just simply type like npm install some libraries, and you can ready to build. But that's the only half of the story. Because even your code was ready, but you still need to machine to run it somewhere. So before the cloud, a startup needs a physical server and a disk. So that means I have an idea. I want to try something new. I want to try some of the brilliant ideas. I need to buy the physical machine. I need to buy disk. I need to buy the cooling system, power contracts, and also I need to hire operation engineer to operate those machines. So even you just try your idea, probably $1 billion need to spend. Now the cloud show up. So you don't need to build your server. You don't need to own your server. What do? You just, okay, I just subscribe the Azure, subscribe to AWS, subscribe Google compute, storage, you just rent it. If your idea is good, you can scale to the million users just a single buttons. But if you fail, you can stop to renting the compute and the storage. So that gives the flexible abilities for the developer to scale their app, and they can try something new very quickly. So yeah, the cloud didn't just change the deployment, it also changed who could build. So a teenager with a laptop and a credit card could now run infrastructures that previously required an entire ID department. So you can see there's so many startups showing up. They are just directly building on the cloud. It's a very efficient ways. Okay, so then we can give another fun fact about AI stuff. So let me give another quiz. Okay, let's give 1 minute to join. Okay, we can just have a 1 more minute. Okay, let's start. Congratulations, NX. Yeah, sorry about the delay. I can later share the question and answer later to the moderators. So moderator can share the questions and answer to the other participants. Okay, let's continue. Okay, let's talk about AI history. So with all programs, what's happening, there was the dream of artificial intelligence. 1950, the Alan Turing, British mathematicians, his 1950 paper, Computing Machinery and Intelligence, opened with the sentence, can machine think? The founding question of AI, the paper introduced the Turing test. I guess someone maybe here heard about that. If a human can't tell whether they are talking to a human or a machine, then the machine is intelligent. 1956, Dartmouth workshop document coined the term artificial intelligence. This is the first time the artificial intelligence was brought up to the public. 1966, Eliza, the first chatbot, was born in MIT. It's a simple pattern match program that's mocked by therapists by reflecting the user's work back as questions. Like, my mother hates me. Then the bot will reply, why do you say your mother hates me? So it's have no real intelligence. It's just simply the pattern match. For example, they search the hate, the keywords, and they will match the questions. Why do you say that? And 69, Shaky built at Stanford Research. The robot navigate the room on its own. And 74, the first AI winter begins. The AI funding is drawn up. So even the researchers who work on AI, they should change the name, like the machine learning. The AI progress stopped for the decades. The main reason because the compute power is not power enough. This machine learning needs a lot of the computer powers. The second is there's no very advanced machine learning algorithm, AI algorithm, to move forward. So the AI research is focused on just based on the rule, based on logic. It's a very limited knowledge. Machine was smart, but very limited. They could only do what the programmers explicitly wrote. No learning, no data, no adaptations. The 80s and the 90s, neural network dies and rise again. So 1986, the backpropagation algorithm was born. This algorithm that lets a neural network learn from its mistakes. After each wrong guess, the error is propagated backwards through the network, and every connection weight is nudged slightly in the direction that could have reduced the error. So you can see now every deep learning model today just is trained this way using backpropagations. The ChatGPT, Cloud Code, every cloudy models. So every currently the large language model using the same algorithm. This is the foundation of the deep learnings. 88, expert system was popularized. The programmers that encoded the knowledge of human experts, just like if-then rules. So they can build the expert system from the mathematicians, the law system. There's a lot of the expert system, but it's not popular because it's no real smart. It's just if else. If they are not matched patterns, the expert system will fail. Then in 1997, there are two quiet earthquakes. The first one is Deep Blue. IBM Deep Blue beats the world champ Kasparov at chess. The first time a machine beats the human at anything serious. Deep Blue used brute force search, evaluated 1,200 million chess positions per second. Yeah, Kasparov said it's cheating. But it's also not real intelligence because it just simply uses the machine power to search all kinds of possibilities. Then, meanwhile, there's a new algorithm called LSTM, the long short-term memory, is invented. The neural networks forgot information after a few steps for the original backpropagation algorithm. But LSTM could remember context across hundreds of steps. So steps learning and plus memory. For 20 years, this algorithm powered Google Translator, Siri, and Alexa. So the transformer eventually replaced them in 2017. But LSTM made modern language AI possible. So 2026, machine can learn. 2006, Hidden called deep learning. The third AI wave coming, neural nets with many layers, hence deep. Each layer learns features at a different level of abstraction and objects. A fast learning algorithm for deep brief net, showing the deep network could actually be trained effectively. And 2011, IBM Watson wins the Jeopardies. And 2012, AlexNet have the image recognitions error overnight. Now the machine can beat human to recognize the image. So after that, almost every lab pivots to deep learning in weeks. So previously we have this tons of the machine learning algorithm like a decision tree, random forest, new Minecraft models. But now almost every single lab using the deep learnings because it's very effective. Why? The main reason is because we have the enough GPU, we have the enough data, we have the deep networks, so makes everything that happens. 2014, GANs, Generative Advanced Network. The main idea is two networks can play a game. So the generator creates a fake data, the judge tries to catch a fakes. They improve together until the fakes are indistinguishable from real, the technology behind the DeepSeeks, and the first wave of AI image generations. Then come to the 2016, AlphaGo beats world champ Lisa Zhu at Go. Why is it important? Because Go has most possible positions in the observer universe. So it should be the billions of possibilities. So that means if it depends on the machine to deploy, to search every single position, it's mission impossible. They need the more advanced algorithm to learn how to play Go. This is the first time experts predict human level play was at least a decade away. Compared to the chess, Go is more complex, and let's AI to solve this problem. So the difference is we have enough GPU, we have the massive data set, we have deep network. So AI that could see, hear, and play without being explicitly programmed how. Then another changes is 2017, the transformer moment. So Google published a paper titled "Attention is All You Need." It introduced the transformer architectures. If you look at all eight, there were 8 authors. They left Google and joined the frontier AI lab like OpenAI, Character AI, Essential AI. This is one of the most cited paper in computer science history. 160,000 plus citations as of 2026. It reshaped the entire AI field. The basic idea, self-attention lets every word examine every other word at once, unlike older models that read left to right. The parallelism is what made training on internet scale text possible. And the 2018's BERT algorithm showing up, Google Transformer variant. So read the text in both direction at once, power Google search starting to 2019. This is the largest single improvement to search equality in a decade. And 2018's GPT-1 showing up. So GPT means generative pre-trained transformer. Generative produce text one word at one time. Pre-trained, first trained on a huge test data, then fine-tuned for the specific task. For GPT-1, there's 170 million parameters. Compared to the tiny GPT, it's small, but it's the template for the everything that's followed. These two children of attention are the parents of everything we're about talk about for the future, the GPT and the Cloud Code, the Geminis. So 2019 to 2021, scale changing everything. 2019, GPT-2, 50 billion parameters. OpenAI called it too dangerous to be fully released. 2020 GPT-3, 175 billion parameters. This is the first model that writes like a human. And 2021, DALL-E draws picture from words. And the GitHub Copilot put AI directly into developer workflows to the first time. November 13, 2022, was that date done? ChatGPT launches. Anyone can talk to AI in plain English. So you can see how phenomenal, the amazing growth. 5 days, 1 million users. 2 months, 100 million users. TikTok took down 9 months. The key innovation wasn't a big model. It was called reinforcement learning from human feedback. So human raters rank the output. So the model is starting to learn to be helpful and safe. Now the ChatGPT moment. Before you wrote every line, syntax, semicolon, every brackets, the computer implements things. After you describe the shape, what do you want? The AI write it. So it's for the first time anyone could ask a computer to write code in plain English. So we are not in the history part of talk anymore. We are in the part that's still actually rewriting itself. So after 2023, AI moved very super fast. So you can see every major lab ships product inside 9 months. ChatGPT-4, a big leap in reasoning and accuracy, and Cloudy launched from Anthropic, focus on the AI safety, security. And the Gemini from Google, there's a multimodal from day one. And for Microsoft, we also have Copilot that become the developer standards. So more than 70% of developers use AI daily. Those 2023 models cross a reasoning threshold. Then they could decompose problems using the tool and self-correct. So after that, the AI tool come into the mainframe of the developers. So developers starting to use AI to write code. Now, we are in the agent era. AI is not just a copilot help you to write code. Now, AI starting to write code for us. As in Microsoft, we are starting to use AI recently, but last year. But now we are almost 100% use AI to write code. So AI not just stop just answering question now. It just started doing the real work. So you can see the first AI software engineer agent, they runs the test code and so on. 24, the cloud code show up, cursor, Windows serve. So agentic coding goes to the mainstream. 2025, multi-step autonomous agents complete the entire project independently. So now agent is not just the language model. It's just, okay, we have agent has memory, agent has tool, agent has feedback loop. Agent can read your file, write your code, even read your email, read your message. They can reply the message for you, reply the email, and do many things. Even agent can automatically generate the content, the publish blog. So everything, almost every job now can be used for agent to improve. It's moving very fast. So every few months, you can see, every few weeks, you can see some new features showing up. So now what the difference is? So previously, we need to write a code, we need to planning, we need to test it, we need to build a pipeline delivery. So now, to simply say, we want to build a game, we just describe what we want. So the AI will do the plan, do the build, do the test, do the deliver. So I will give the live demo now. I believe many of you already use AI to write a code, but I still just want to show how AI to quickly build a demo, build the game. Let me give so now I use Codex. So I already gave the describe in the text file. So now I just let AI set read this text file and create a game based on the descriptions. So the AI can starting to build and learn the problems, reading the skills, and doing the planning. So AI also will ask to clarify the questions. Yeah, so just to simplify, for the real industry, definitely not. So we need a planning, we need a testing. So okay, to simplify, I already using the prompt to generate the game. So you can see the final game, it looks like this. Yes, it's starting to write a code. But anyway, so that to save time, so we can play the game. So yeah, so you can try to using the prompt to build it using the Codex or Cloud Code. Okay, let's moving forward. So yeah, basically, I want to talk about a little bit about the software engineering changes. So previously, when we write the software in the big company, it has many steps. The first step is planning. So we have we call the product manager. The product manager need to write the feature spec. And we need to have a lot of meetings, write a doc back and forth. It takes weeks or days or weeks. Then later, when we finalize the feature spec, then we are passing this feature spec to the engineer. The engineer will design based on this spec. They roll out the diagram. They will find the functional requirement, non-functional requirement, and give consider all the edge cases. After we finalize the design, then we'll move to the next stage, is implementations. The engineer is based on the design spec, write the code, write the individual function. After that, we also need to write a unit test. If the unit test fail, or we need to continue to find the bugs, repeat it again and again until you hit a high unit test coverage. After that, we ship the product into the testing environment. Then we are testing the function tests, end-to-end tests. Everything is ready and no major issues. Then we are build a release pipeline to release product to the real environment and let the customer to use it. Then it's still also a lot of the human work. But now the AI has changed everything. So even in the big company and the startup company, either big company, startup company, we use AI to simplify everything. So now you have a problem, you can just simply describe what you want and use AI to do the planning, make sure everything ready. So now even engineer, we can build a spec by ourselves. Even PM don't need an engineer to write a design code. PM also can build to have design and the code. So AI can do planning, can do the design, can do the coding, and could do the testing. And AI can also help to release the ship, but it's very challenging because we don't fully trust AI to ship the product directly. We still need a human to review before shipping and run all kinds of tests. But in futures, I believe with aging more powerful, with the security, the agentic security are more reliable, I believe aging can also to do the entire end-to-end, the software in industry. So let's zoom out. So everything from Turing in 1950 to GPT-3 took 70 years. Everything from GPT onwards has to take 3. So entire 3 years, we're moving very fast. And the AI can write code, can answer questions, can do the many different jobs now. So this is where we are, and this is why programming will never look the same again. So what does it mean for you? So previously, we need to learn a lot of the programming language. We need to learn the operating system. We need to learn the database. We need to many years networking, years the computer science studies. Then we can build some real things. Now it's different. Now all we need to do is we have the problem descriptions. You can understand how to break a big, massive problem into the pieces. Then AI can do the job for you. But how can we measure? How can we measure the AI program? AI code is good enough or bad code or the good code. So you still need judgment and the dominology and the programming understanding to understand the AI general code is good or bad. So need critical thinking, critical evaluations is very important. The number 3 is communications. Now, previously, we write code one by one. But now what you need to do is, okay, you need a clear language to describe what you want. Tell AI what exactly you are looking for. Then the AI can do the rest of the work for you. But my suggestion is still, you need to understand the language. You still need to learn how it works. Then it's very helpful for you to make a judgment. What's the good code? What's the bad code? Or from a systematic thinking, is this reasonable or not reasonable? Okay, the last one, back in 1975, to build something, you need a garage, you need a hardware, you also need years of self-learning electronic experience. But only very few teenagers can do that, and only few agents try out. But in 2026, to build something, you just need a laptop and an idea. So basically, you can do everything you want now. Nobody can stop you. You can build a website, you can build a game, you can build a productivity tool. So everything you can build. Even you don't need to go to college. Even you can just go to use the Codex, your Cloud Code. You said, I want to build something. The Codex and Cloud Code can do now. Copilot also can do the same job. So don't wait for permissions. Just start building. So you have better tools than ever and anyone before in history. So what will you build? Thanks, everyone.
All right, thank you, Chen Chao, for coming today. As we are running a bit late, we will get right into the contest winners and raffle winners. So we will only be covering pre-college teams in the following slides, and we will begin with the novice division. So for our runner-ups, in fourth place, we have the Finite Automata, and we have Ted Shi, Serena Chin, Norbert Liu, and Ayush Biller. So congratulations. And in fifth place, we have Hardstuck Yusuko Silver with Lucas Zhang, Cynthia Zhang, Ethan Hao, and Luke Guo. In third place, we have 5 orangutan emojis with Danny Wang, Sidhant Aurora, and Jonas Wong. In second place, we have C++ is my mother tongue with Chong Hong Cern, Viren Ayapa Vakulu. And in first place, we have publicly declaring we will not actually cheat. And we have Jonathan Zhang, David Fu, Ryan Chi, and Ethan Chan. So congratulations to all of our novice participants. And here's the list of the winners. In our advanced divisions, for our runner-ups, in fourth place, we have Lithium with Daniel, Lindsay, and Ellen. And in fifth place, we have One Camper, 3 Mangoes with Siv, Brian, and Denny. For our third place team, we have first place team with Brian Zhao, Derek Lee, and Harren W. In second place, we have STDAC with Ethan, Jerry, and Jesse. And in first place, we have Coder Bunny Fan Club with Sonit and Kalia. So congratulations to all of our advanced winners today. And here's the full list. You will shortly be able to see the full leaderboard on the contest website after we unfreeze the leaderboard. The standings will be up for a few days after today. The problems will also soon be added to a Code Forces gym where you can upsolve the problems. Congratulations to everyone who placed, and a huge thanks to everyone that participated. We'll post the winners of today's contest to our website shortly. Don't be discouraged if you don't win anything, but you still have the chance to win something in the raffle, which we will move on to right now.
There are a lot of great prizes to be won here, so good luck to everyone. Let's pull up the spinner and see who wins. First, we have 10 Discord Nitro subscriptions. The winners are Muhammad Ishaq, Michael Xiang, Girish Vishwanath, Mohammed, Aiden Wei, Anton Backett, Violet Flores, Cynthia Jean, Patrick Dane, and Ahmad Shahzad. Congratulations for winning Discord Nitro. Secondly, we have the Red Dragon Gaming Keyboard and Mouse. The winner is Thomas Chan. Congratulations to everyone who won a raffle prize as well. As a disclaimer, these raffle winners may not be final as there are many participants that were disqualified. Please check our Discord for potential changes in the winners list. If you won a placement prize today, have one team member send us an email at contact@teamscode.org. The email must include the following information: team name, rank and division, full name, and email address. If you won a raffle prize today, the email must include the following information: team name, division, full name, email address, and mailing address. If you sign up for XCamp using the coupon code, also email us with team name, division, full name, and email address. If we do not receive an email from you within 7 days, which is May 3rd, we will not be sending prizes to you. We'd like to give a big thanks to XCamp and Non-Trivial for making these awesome prizes available to you. Without them, our contest would not have been possible. Thanks again to everyone who took time out of their day to compete. We hope everyone had a great time today, and we look forward to seeing you again for our future contests. Before you go, we'd greatly appreciate it if you could subscribe to our YouTube channel, follow our social media accounts, and fill out our feedback form. Additionally, our TeamsCode Organizer applications are open for all of our roles. Being a TeamsCode Organizer is a unique opportunity to work directly with USCO finalists and IOI medalists, and they also count towards volunteer hours. Additionally, being a logistic coordinator requires no prior experience. Please consider applying. Have a great rest of your day, and we hope to see you at our next contest.